Sometimes we need to do a more in-depth comparison of objects of the types that we create, like our books, than just an equals will allow. Testing equality is nice and useful, but if we want to be able to order them, such as putting them into a sorted array or a binary search tree, then we're going to need to write a CompareTo function. In order to work through an example of this, I've modified that book class that we've looked at before. I wrote it to extend item, similar to our library one we've seen in a project before, except I pared down item quite a bit so that now all it does is two things. It specifies a generic type k that will extend comparable, which really just means that whatever type this k is will have a CompareTo function, a CompareTo method. And then it specifies one field, one instance variable called key that is of type k. And that will be the value we'll be able to use for any type of item. We can compare their keys for them so that we can compare books to other books and so on. So you'll also notice that in the book class, instead of storing the ISBN as a variable that comes from the book class, I designate it to be my key, so that when I write my CompareTo function, I'll be able to just use that key and compare items to other items, books to other books. You'll notice that I cannot run my main method like I could before with equals, because CompareTo is not built in. There is no automatic CompareTo function for all objects like there is for equals. We'll have to create ours. So CompareTo returns an integer, negative, positive, or 0, based on which item is greater than the other. And it needs to, in our form, take an object so that we will eventually do that thing that's kind of cheating for Java rules, where we will be able to compare to more than just our own type, more than just books, so that we can take in an ISBN and compare to that as well, to tell, for instance, where that ISBN might need to go if it's getting inserted into our sorted list or binary search tree or whatever. So we check if O is an instance of book. And if it is an instance of book, then we can just compare the book's keys to each other, their ISBNs to each other. First, I need a variable to store a version of O that gets cast to be a book. This tells Java again that we know that O is a book. We just checked it. So go ahead and turn it into a book variable so that I can call book methods on it. And then I'm going to return the key compared to B's key. And that should work perfectly fine for my comparisons between books. Now, with CompareTo, we can't just return like false like we did before with equals. So I'll just say 0. They're all equal for any other type, which again is a little fuzzy. Doesn't work perfectly, but it will give us, it will let us do the book comparisons and run for those. And we can even run for the others. It's just going to say everything is equal if it's not a book, which is bad behavior for now, and we'll fix it. So we have The Hobbit compared with Pedagogy of the Oppressed, returning -5 because the ISBN of The Hobbit is a lower number or lower ranking string than the ISBN for Pedagogy of the Oppressed. I had to use strings for these to do a quick comparison because they'll be of varying lengths, and they'll be equal length, but they will be too large for an integer, and I didn't want to mess with other types. Now, if I reverse that comparison and compare Pedagogy of the Oppressed to The Hobbit, I get a positive number because the first thing has a higher ISBN than the second thing. If I compare a book to itself, like The Hobbit to itself, I get 0. So we see our CompareTo gives correct behavior for those. Then when I want to do those ISBN comparisons, they are allowed, but they're not correct necessarily. They return 0 always because I programmed it to return 0 for all other types. So now if I want to compare with just an ISBN, again, if I was looking for where to insert a new book into my data structure, that would be a perfectly good use. I don't want to have to create the whole book object. I might not even know the whole book object. I might be doing a lookup in a sorted array or in a binary search tree or something, and all I know is the ISBN. So I need to have an else case for being able to compare with the key only with the other object. And to do that, because of the way I've structured this, I'm able to just write an else case, return key compare to the object, and I can remove the return 0. So now I have a pretty similar structure to what I had for my equals. If it's a book, I take the key from my book and compare it to the key from that other book, so that if someone gives me a whole book object, I'm able to look stuff up. If it is not a book, I can return the key compared to that object. If that object is a string, for example, to compare with my string key, then I'll be able to do comparisons like I've got down here, where I take the ISBN for The Hobbit and compare it with some books. Now again, remember the order on this will matter, and this is where we've broken Java conventions a little bit. I ought to be able to reverse and say ISBN.CompareTo B1, but strings don't know how to compare to books. Books know how to compare to strings because I wrote the CompareTo function that way. So this breaks the rules a little bit, but again, it adds that possibility that we can search through based on an ISBN and see if a book is already in our list, get the author, look up its other information, remove it based solely on the ISBN, etc. So we can see that The Hobbit's ISBN matched with The Hobbit, the book, down here, and that The Hobbit's ISBN did not match with Kindred's book. So we have correct behavior for both of those cases. And now we're able to do those lookups based on just the key information, or to sort data, or to do whatever else we needed to do, comparing our books to each other or our books to their ISBN, the type of their key.